All right, screw the formalities. Let's get this silicon shit show on the road. Apple silicon, baby. From those little pocket rockets and iPhones to the goddamn behemoths they're cramming into Macs these days.
Mountains of Wikipedia articles here, ready to dissect these chip series like a frog in biology class.
A series, M series, S series. Hell, they've got a chip for every letter in the alphabet.
Alphabet soup of silicon, and we're here to spoon-feed you the good stuff.
Performance leaps. Tech that'll make your head spin.
Maybe even a few holy shit moments along the way. Let's kick things off with the A series, the engine in iPhones and iPads for over a decade.
So the A series, it's like Apple's gym rat. Always hitting the weights, getting bigger, faster.
Basically. Trace the evolution from the A4, their first in-house chip back in 2010, all the way to the A18 Pro dropping next year. Each generation squeezing more power, more efficiency.
Don't forget the A17 Pro, the first 3nm chip. Yeah. Like cramming the entire Library of Congress onto a postage stamp.
Mind-boggling engineering. Billions of transistors on a chip the size of your fingernail.
Not just raw power, though, right? The battery life on these things. Remember when iPhones died after like 3 hours?
Dark times. Big change happened when they ditched Samsung for TSMC, starting with the A8. TSMC's process technology is top-notch, allowed Apple to really push the boundaries.
TSMC, unsung heroes of the silicon world. They're like the guys making picks and shovels during a gold rush.
Good analogy.
Yeah.
And the A12 Bionic, another milestone. First 7nm chip in a smartphone. Huge leap for power and battery.
Okay, so tiny, powerful chips. But what the hell is this fusion architecture thing? Some silicon orgy where all the cores get together and swap bits?
Not an orgy, but different cores working together. Fusion combines high-performance cores, the muscle cars, with high-efficiency cores. Think those little eco-friendly scooters.
A tag team of processors. Clever bastards.
High-performance cores kick in for demanding stuff, gaming, video editing. High-efficiency cores handle everyday tasks, email, web browsing. Best of both worlds. Speed when you need it, battery life that doesn't suck when you don't.
And then there's the neural engine. Straight out of a sci-fi movie, what's the deal? My phone secretly plotting to take over the world?
Not Skynet, but impressive. Dedicated processor for machine learning and AI.
Brains of the operation, huh?
You could say that. Facial recognition, voice processing, those personalized ads that seem to know what you're thinking. A lot of the cool camera features, too. Portrait mode, deep fusion, all that.
Okay, but real talk. Neural engine is also why those targeted ads are stalking me across the internet, right? I look at a pair of shoes online, now they're following me everywhere.
It does play a role, but let's not get sidetracked by the ethics of targeted advertising.
Fair enough. We've got a silicon empire to dissect. Where do we go from here?
Before the M series, worth mentioning the A5X chip in the third-generation iPad, a beast twice the size of NVIDIA's Tegra 3 at the time, all about graphics performance.
Planting the seeds for desktop domination. Laying the groundwork for the M series, those chips that finally made Macs ditch Intel and go full Apple.
Sharp observation. And that transition, my friend, is where things get really interesting. All right, on to the main event, the M series.
Where Apple basically said, screw you to Intel, and went full rogue with their own desktop chips.
Bold move, yeah. PC industry was Intel's playground for decades. Apple was betting the farm.
And boy, did they deliver. Remember the first M1, like the second coming of Steve Jobs? Everyone losing their minds over the performance.
Game changer. The M1, built on a 5mm process, ridiculously powerful, energy efficient. But the real standout was the unified memory architecture.
Unified memory sounds like some hippie commune for silicon bits.
Okay, imagine you have two hungry kids, both want cookies from the same jar. In a traditional computer, the CPU and GPU have their own separate jars. Slows things down.
Cookie grabbing bottleneck.
Right, unified memory. It's like putting all the cookies in one giant jar. CPU and GPU share the same memory pool. Faster data transfer, better performance.
Let's talk cookie fights. Everyone's happy, munching on cookies, and the computer runs like a cheetah on speed.
You got it. And the performance gains were insane. The M1 destroyed comparable Intel chips in benchmarks, especially for video editing, 3D rendering, wake-up call for Intel, for the whole PC industry.
Intel must have been shitting bricks, their monopoly crumbling before their eyes.
The impact was huge, but Apple didn't stop. They kept going M1 Pro, M1 Max, and then the M1 Ultra.
The M1 Ultra, like they took two M1 Max chips, smashed them together with a sledgehammer, and somehow made something even more powerful.
Well, not quite that brutal. The M1 Ultra used something called ultrafusion, basically a silicon interposer connecting two M1 Max dies.
So like a silicon bridge letting those two chips have a data orgy?
Not exactly, but you get the idea. Ultrafusion lets those dies talk to each other at crazy speeds, essentially one massive chip with insane performance.
Video editors, 3D artists, musicians. Everyone creaming their pants over the M1 Ultra.
Major win for Apple. Cemented their position as the leader in chip design. And they haven't slowed down. M2, M2 Pro, M2 Max, M2 Ultra, each generation pushing the limits.
Silicon leapfrog, each new chip jumping ahead of the last one.
And it's not just raw power. They're adding dedicated hardware for specific tasks, machine learning, ProRes encoding, making the chips smarter, more specialized.
Not just brute force. Finesse, optimizing every transistor for max performance and efficiency.
Exactly. And this is huge for creative pros. Video editors can work with 8K footage without breaking a sweat. 3D artists can render complex scenes in a fraction of the time.
Apple gave everyone a goddamn superpower upgrade. And it's not just the pros. Even your average Joe can edit 4K video on a MacBook Air without it sounding like a jet engine.
High-end computing for everyone. And with the M3, M3 Pro, M3 Max already out there, rumors of the M4 series, Apple's just getting started.
Okay, before this turns into an M series love fest, let's talk about the little guy, the S series, the brains of the Apple Watch.
Ah, the S series. Not as flashy as the M series, but it shows Apple's skill in miniaturization and power efficiency. Tiny chips designed to fit in a smartwatch.
Pocket rockets of the Apple Silicon world. Small but mighty.
Exactly. But they pack a punch, powering all those health tracking features, apps, even cellular connectivity.
What's with the system in a package, or SIP thing? Fancy marketing bullshit.
It's about integration. Imagine a tiny self-contained computer in a single chip. Processor, memory, storage, all working together seamlessly.
A chip within a chip within a chip.
Yeah.
It's like a silicon turducken.
Well, not exactly, but you get the idea. It's about packing tons of functionality into a tiny space. And Apple's refined these SIPs with each Apple Watch generation. More processing power, new sensors like the always-on altimeter in the S6, 64-bit architecture with the S4.
Always on altimeter. So I can track how many flights of stairs I climb while I'm stuffing my face with pizza.
Well, it's for hiking, tracking elevation changes during workouts. But hey, pizza-related data gathering works too.
But what blows my mind is that the Apple Watch has a neural engine. That tiny thing has AI.
Yep. Starting with the S4, the Apple Watch got the same neural processing power as iPhones. On-device machine learning, fall detection, personalized heart rate algorithms.
So my Apple Watch is learning my habits, tracking me, judging my pizza consumption.
Let's keep the stalker metaphors to a minimum. Finally, we have the W series chips, the ones that handle wireless connectivity, Bluetooth, and Wi-Fi.
Because those are kind of important for, actually using the damn things.
The W1 chip and the first AirPods revolutionized wireless audio, seamless, reliable connection. The W2 and W3 chips in Apple Watches made wireless even better.
So Apple's got their Silicon Army covering all the bases. Processing power, security, wireless. A chip for every occasion. It's like they're building a Silicon Death Star.
Let's not get ahead of ourselves, but their control over their silicon gives them a massive advantage. They can optimize everything, hardware and software, to work together perfectly. Creates an ecosystem that's tough to beat.
So what's the takeaway for the average user?
Apple is all in on silicon, and they're winning. Their chips are in some of the most desirable gadgets on the planet, and they're not letting up.
So if you're still clinging to that old Intel Mac, maybe time for an upgrade. The future is Apple Silicon, and it's looking pretty damn good. But hey, that's just our take.
Indeed. Take it with a grain of salt.
All right, we're going to grab another whiskey and think about the existential dread of Apple's silicon dominance. Back in a bit to wrap things up with some final thoughts and maybe some crazy predictions about the future. Don't go anywhere. We're back, you magnificent bastards. Whiskey topped off, brains sort of rebooted, ready to wrap up this silicon saga.
A series, M series, those little side hustle chips, S and U.
It's like Apple built their own Silicon Death Star, and they're aiming it right at the tech world.
Vertical integration, that's the key. Designing their chips means they can make everything work together perfectly. No more relying on other companies.
Yeah, no more compromises. They're calling the shots, and it's working.
Like they built a Ferrari engine, then crafted the whole car around it. Every little thing designed to squeeze out the most performance.
And that's why things are getting blurry. iPhones are more powerful than some laptops. Macs are getting features we only saw on phones and tablets.
A silicon melting pot.
More like a hybrid superspecies of devices, all powered by their own silicon. The rest of the tech world is trying to catch up, but they're like dinosaurs trying to outrun a meteor.
It makes you wonder, will we see one device that can be a phone, a tablet, a laptop? Will those categories even matter anymore?
Dude, mind blown. A device that morphs from a sleek phone into a powerful workstation, like a transformer, but instead of a robot, it's your whole digital life.
Who knows? But Apple's silicon strategy is working. They're not just following the market anymore, they're leading it.
And they're doing it with this whole secrecy thing, this exclusivity. Makes people want their products even more. Like they're the Illuminati of tech.
Masters of marketing for sure,
Yeah.
but the real magic is in the silicon, and it's just getting crazier.
So what's next? An M-series chip so powerful it can launch a rocket into space. Will my Apple Watch become self-aware and demand to vote?
Let's not get carried away. I think they'll keep refining their chips, pushing performance and efficiency. Maybe we'll see more specialized chips for things like AR, VR, or AI.
So they're not going to rest on their laurels. They're going to keep innovating, keep making everyone else look like amateurs.
Exactly. They have the freedom to take risks, to experiment in a way that other companies can't.
Apple's silicon story is just getting started. It's a runaway train, and it's not stopping for anyone.
And if you're still rocking an Intel Mac, well, you might want to jump on the Apple Silicon train before it leaves you behind.
All right, folks. That's our deep dive into the crazy world of Apple's silicon. From the A series to the mind-blowing M series.
We've seen how these chips work, figured out Apple's silicon alphabet soup, and thought about what it all means for the future.
We've had some laughs, learned some stuff, probably pissed off a few people, but hey, that's what we do.
Keep your eyes on those transistor counts, and remember, the future is silicon.
Catch you later, you beautiful bastards.